Hi guys, welcome to Algebra 1, Semester 2, Day 15. Today, this is the second part of our lesson where we are looking at finding the solution to a linear inequality in two variables. So now we're going to have both x's and y's. So here's what we know. A linear inequality is similar to a linear equation. However, it's going to use an inequality symbol instead of an equality symbol. So instead of an equal sign, you're now going to see that you're going to see that inequality symbol. The solution to a linear inequality is going to be all of the ordered pairs that make the inequality true. So you're going to be shading a region of your graph because the line that you're going to graph is going to be kind of like a boundary, and it's going to split the inequality into two pieces. Part of the graph is going to work, part of the graph is not going to work. So let's look through a couple of examples to figure out what I'm talking about whether or not it's going to work. So to determine which ordered pairs are solutions to the linear inequality, we want to take our ordered pair, remember that this is an x and a y, and we want to plug that into the equation. So we would take 2 times x, which is 2, minus 3 times y, which is 5, is less than 15. And really what we're asking is that true? So 2 times 2 is 4. Negative 3 times 5 is negative 15. 4 minus 15 is negative 11. And so we're asking, is negative 11 less than 15? And the answer to that question is yes. So on our graph, we would want to find that point, and that's the section of our graph we're going to shade. Let's try one more. So is 2 times negative 1 minus 3 times negative 7 less than 15? 2 times negative 1 is negative 2. Negative 3 times negative 7 is positive 21. Negative 2 plus 21 would be 19. So we ask ourselves, is 19 less than 15? And the answer is no. So that part would not be shaded. We would find the part of the graph where negative 1, negative 7 is, and we would leave that half of the graph blank. So I would like for you to try the next two. When you're done, come back and we'll talk through them together. So go ahead and pause the video now, try the next 2 points, and then come back together and we'll talk. All right, so the point 3, negative 4 gives us the inequality 18 is less than 15, which is not true. Then we want to try the point 0, 0. I like testing the point 0, 0 because it makes everything with x and y go to 0. So it's going to be the easiest one to do. So 0 is less than 15, which is true. All right, we're going to talk about some shortcuts for graphing these. The first thing that you're going to want to do is you're going to want to put the inequality in what's called slope-intercept form, which means that we want to solve this for y. And again, if you multiply or divide by a negative number, you're going to want to flip that inequality symbol. So let's take a look at our example, and we're going to work through that piece of this together. So we want to get y by itself. That's the goal. So we want to move that 2x to the other side, and we have to do the opposite to it to get it to move. Now, adding and subtracting isn't going to mess with the inequality symbol, so it's going to stay as less than negative 2x plus 15. Then we can divide everything by negative 3. And notice that this is where we're going to have to switch the symbol because we're dividing by a negative number. So now y is greater than negative 2 times negative 3. We're going to leave that as a positive 2/3. Leave it as a fraction because that's your slope. And then plus 15 divided by negative 3 would be minus 5. So then we go to our graph. We start at negative 5. And we're going to go up 2 over 3, up 2 over 3. Now, when we graph the line in step 2, we want to use a solid line for the greater than or equal to or the less than or equal to symbols. So if it's equal to, we want to connect the dots. If it's not, we want to use a dotted line for the less or the greater than or the less than symbols. So because in this case we have just the greater than symbol, we're just going to have a dotted line to represent the dividing line of this graph. Now, the next step of this project or process is to shade the graph. If we have a greater than symbol or a greater than or equal to symbol, we're going to shade above the line. If we have a less than or equal to symbols, we're going to shade below the line. We can always test a point to double check to make sure that we're correct. So in this case, my symbol is a greater than symbol. So that means we're going to shade in the top half of this graph. And I just usually kind of do a light shading like this. Now we can always test a point. So I like to test the point 0, 0. As long as that point's not on your graph, it makes a great one to test. So we can go 2 times 0 minus 3 times 0. 0 minus 0 is 0. So is 0 less than 15? And the answer to that is yes, which is good because it's in that region we shaded. Now, that's one way to go through this to double check to make sure that we know which way we're going. That's the basic idea. So the first step is you want to put the inequality into slope-intercept form. Then you're going to graph the line. You're going to connect the dots with a solid line if you have the equal to symbols. You're going to leave it as a dotted line for the not equal to symbols. Then you're going to shade above the line for the greater than symbols and shade below the line for the less than symbols. You can always test a point to make sure that you've shaded the right side of the line. The rest of your independent practice today is to complete the odd problems on this page. I'm actually going to take one more off of there for you. We're going to take off problem number 7. So you really just have to do problems 1, 3, and 5 to finish up the independent practice of today. All right, we've got one day left. Keep up the good work. We're almost there. Thanks, guys.